All right, part three of covalent bonds. We looked at the VSEPR theory and how that can determine shape by looking at that chart. In order for these molecules to form, all right, they can't form in a regular atomic orbital. It has to be a bonding orbital. And hybridization basically is a combination of two of the orbitals. Like just as a hybrid car would have electric and gas. Hybridization is the mixing of two orbitals. And it can be the S, P, D, or F. What we're going to focus on are just the simpler ones, which are going to be the S and the P orbitals that are going to come together. So, in doing so, count the number of bonding areas. And if you remember the electron dots that we showed, how we would put dots on the top, the bottom, the right, and the left, gives us four areas that you possibly could. Depending on if there's going to be a double or a triple bond, it could then take away from some of those areas and it wouldn't be able to bond. So if we look at anything that would have four bonding areas, it would be a combination or a hybrid of the S in all three P orbitals to make that. Any single bond's going to be in that, or an unshared pair is still an area that it could have bonded in. So it would still have all four areas. In order to get a three bonding areas, you have to have a double bond in there somewhere. And a double bond will then give us an sp2. It's a hybridization of the S and two of the P orbitals in order to make up that double bond. And then you could either have a triple bond or some type of thing that's going to give us two bonding areas. Probably should have been a space in there. Two bonding areas is just the S and one of the P's hybridization or hybriding in order to allow that bond to happen and that molecule to form, or it wouldn't form. Brings us to one of the last things we talked about in chapter 8 as far as a review was the idea of polarity. Covalent bonding, as we had already learned earlier, is the sharing of electrons, but the question is, do they share equally? And the answer is no. Not all molecules share electrons equally. It's basically a tug of war, and we're trying to find out which one wins. If it is equal sharing, then we call that a nonpolar. That means it doesn't have polarity. Polarity means poles, positive and negative sides, which is then going to allow other molecules to stick to it. So you get nonpolar if they're sharing equally. If it's unequal sharing, it's called a polar bond. And which one is going to receive the electron more? It's going to be the one that has the more electronegative value. And it's going to give that one, because it's getting the electron more, it's going to, a portion of the molecule is going to be more negative, and then there's going to be a portion that's more positive. Here's a table of electronegativities that we talked about in chapter 6, with the periodic table, with fluorine having the most, basically being the strongest at tug of war, and francium down here at the bottom being the weakest, as far as that would go. What you want to do is find out this DEN stands for a difference in electronegativity. So if I want to know if the bond is polar, you subtract the two electronegativities from each atom. And if it's between 0 and 0.4, it's nonpolar. We said basically 0.4. I would even go up to 2. I know this chart I put on here is only 1.7, but I'd go up to 2. It would then be ionic. So 0.4 to about 2 is going to be polar. I didn't have you distinguish between moderately polar and very polar. It was just, is it polar? It's nonpolar, polar, or ionic, one of those things. How you would go about doing it, if we consider the bond between HCl, which is hydrochloric acid, basically we look at their electronegativities. Hydrogen is 2.1, chlorine is 3.0. We then take the difference, which is subtraction, gives us 0.9. Go back to the table, and you'll see that that is going to be polar. So, and which one's higher? Well, chlorine, so it's going to have the negative side, and hydrogen's going to be the positive side. We put the positive as an arrow always pointing towards the one that's more negative, because in doing so, it is going to get the electron more. Put a little dash on the side because this shows us positive, this shows us negative.